Mid-1941, inside his Berlin office, Hermann Göring, the all-powerful chief of the Luftwaffe, dismissed the United States with a curl of contempt. "They cannot mass-produce fighters or train pilots fast enough to matter," he scoffed, confident that America was nothing more than a nation of amateurs, a country whose factories could never forge a real air armada or challenge Axis air power. To Göring, the idea of the US Navy commanding a vast fleet of modern carriers was little more than fantasy. But the irony was already in motion. Within just 2 years, the United States would ignite an industrial engine unlike anything the world had ever seen, unleashing tens of thousands of aircraft and the mighty Essex-class carriers that would sweep across the Pacific and shatter every assumption Germany once held. At the outbreak of war in Europe, the United States stood on the sidelines with an industrial base still recovering from the shock of the Great Depression. In 1939-40, American aircraft output remained painfully small, a fraction of what a global conflict would eventually demand. According to the Army Air Force's Statistical Digest of World War II, US factories produced just 3,611 military aircraft in 1940, a number that reflected a peacetime economy, modest defense budgets, and a nation not yet mobilized for total war. American industry was powerful, but it had not been asked to fight a mechanized conflict on a global scale since 1918. Meanwhile, the Luftwaffe's early war performance projected an image of unstoppable momentum. In 1940 and early 1941, German air power smashed Poland, the Low Countries, and France through the rapid, coordinated violence of blitzkrieg. Luftwaffe pilots were battle-hardened, its aircraft modern, its doctrine aggressive and effective. To German planners, this superiority was evidence enough that no distant industrial nation, least of all the United States, could challenge their mastery. They saw America as lacking both the technical sophistication and the organizational discipline to field a true air armada or sustain a large-scale pilot training pipeline. The phrase "country of amateurs" became a comfortable shorthand for dismissing the industrial potential of a rival they barely understood. American naval power appeared equally unthreatening. By 1940, the US Navy's carrier force consisted essentially of 3 major pre-war flat tops: USS Lexington, CV-2, USS Saratoga, CV-3, and the Yorktown-class carriers. These ships were capable but born from the constraints of interwar naval treaties. To Berlin, this small fleet signaled that the US could never deploy a vast carrier force across the Pacific or the Atlantic in any reasonable time frame. Yet beneath the surface, a transformation had begun. Industrial giants like Ford, General Motors, and Douglas quietly retooled their lines, experimenting with new production methods and wartime conversion. Inside the Navy's Bureau of Ships, architects drafted the blueprints for an entirely new fleet carrier, the Essex class, designed for rapid wartime construction. Even before America entered the war, the foundations of the future arsenal of democracy were already taking shape, waiting only for the signal to ignite. The transformation of American industry did not happen by accident. It was the result of deliberate decisions, national coordination, and a scale of mobilization unmatched in modern history. The turning point came on December 29, 1940, when President Franklin D. Roosevelt delivered his now iconic Arsenal of Democracy speech. Speaking to a nation still technically at peace, he declared that the United States must become the great arsenal of democracy, a manufacturing powerhouse capable of supplying not only its own defenses, but the survival of the entire free world. That single message signaled the end of American industrial hesitation. Suddenly, corporate executives, labor leaders, engineers, and government agencies were no longer working in parallel. They were working as one, pushing toward the singular objective of total wartime production. Factories that once built refrigerators, automobiles, and household machinery began reorienting toward engines, fuselages, machine tools, and precision components. Within months, this political commitment took institutional form. In early 1942, the United States created the War Production Board, WPB, an organization with sweeping authority over resources, manufacturing priorities, and industrial conversion. The WPB controlled the allocation of steel, aluminum, rubber, fuel, and electrical power, materials essential for aircraft and naval construction. It standardized components, eliminated bottlenecks, and enforced streamlined processes. Crucially, it coordinated the conversion of America's enormous automobile industry into a producer of aviation engines, aircraft frames, and subassemblies. Under WPB oversight, assembly lines once dedicated to civilian consumer goods became the arteries of an industrial war machine. The results were staggering. Production of military aircraft, a key benchmark of wartime output, grew with explosive speed. The Army Air Force's Statistical Digest recorded 1940, 3,611 aircraft, 1941, 18,466 aircraft, 1942, 46,907 aircraft, 1943, 84,853 aircraft, 1944, Jan Aug, 96,270 aircraft. From July 1940 to August 1945, the United States produced 295,959 military aircraft, a figure so large it dwarfed the combined output of the Axis powers. This surge was no mere mobilization, it was a redefinition of industrial possibility. Much of this success came from the rapid conversion of major manufacturers. Ford's Willow Run plant became legendary, assembling the consolidated B-24 Liberator at peak rates of one bomber every 59 minutes, a feat unthinkable before the war. Aviation giants scaled to astonishing totals. North American built 41,839 aircraft, Douglas produced 25,569, Consolidated Vultee 27,634, Curtiss 19,703, and Lockheed 17,148. Even the aluminum industry, the lifeblood of aircraft frames, expanded several times over after 1939, ensuring that raw material supply would never choke production. In parallel with aircraft production, the US Navy embarked on a carrier-building program that would transform naval warfare. The Essex-class carriers, designed as emergency wartime platforms, became the Navy's new backbone. Their features reflected the hard lessons learned from early Pacific battles: armored flight decks, larger hangars, expanded fuel stores, and more robust anti-aircraft defenses. A total of 32 Essex-class carriers were ordered, with 24 laid down and 14 seeing combat in World War II. Their construction emphasized modular design and standardized components, enabling shipyards to accelerate production far beyond pre-war norms. The lead ship, USS Essex, CV-9, laid down in March 1941 and completed by December 1942, exemplified this speed. Displacing 34,000 to 37,000 tons and capable of exceeding 32 knots, each Essex could embark 90 to 100 aircraft. A floating airfield engineered for the demands of modern naval air warfare. This dual rise of aircraft output and carrier construction created a self-reinforcing advantage. More planes required more carriers required more planes. Together, they formed a production loop so powerful that neither Germany nor Japan could compete. Every battle the United States fought after 1943 was supported by a seemingly endless supply of machines, spare parts, and trained crews. For Göring and the German High Command, this development exposed a fatal miscalculation. They had assumed American industry resembled European wartime economies, limited by resources, constrained by geography, vulnerable to disruption. What they failed to recognize was the scale, flexibility, and mechanized efficiency of US mass production. As America shifted into high gear, the Luftwaffe and the Kriegsmarine faced an opponent whose factories operated with mathematical precision and relentless tempo. By 1943-44, the United States achieved complete overmatch, not through sheer luck, but through the industrial logic that Göring once mocked. By mid-1944, the United States Navy sailed into the Central Pacific with a level of power projection that no Axis planner had believed possible. The Essex-class carriers, symbols of the industrial miracle unfolding back home, now formed the core of a fast-moving strike force capable of projecting hundreds of aircraft across vast ocean distances. When the next major confrontation came, the results would prove just how lethal American production and naval aviation had become. A Battle of the Philippine Sea, June 19, 1944, the situation before the battle. By June 1944, U.S. naval dominance in the Pacific was unmistakable. The Essex-class carriers had begun arriving in numbers, replacing the thin pre-war carrier force and giving Admiral Raymond Spruance a mobile, resilient offensive armada. Several of the most modern Essex-class ships, USS Essex, USS Yorktown, CV-10, USS Hornet, CV-12, and others, were fully operational and positioned to support the invasion of the Mariana Islands. Their combined air wings represented nearly 1,000 combat-ready aircraft flown by pilots trained through the massive American aviation pipeline that Germany and Japan could no longer hope to match. The battle and its numbers. The clash that followed would be remembered as the Great Marianas Turkey Shoot. When Japanese aircraft surged towards the American fleet, U.S. radar, disciplined formations and carrier-borne fighters responded with devastating accuracy. Estimates vary slightly across sources, but the picture remains unmistakable. Japan lost approximately 300 aircraft. Many accounts specify Puku 272, while American losses stayed below 100, with figures often cited around 75. Each Essex-class carrier fielded roughly 9,100 aircraft, giving American task groups a dense shield of fighters and dive bombers capable of intercepting waves of Japanese attackers long before they could threaten the fleet. For every Japanese formation destroyed, replacement aircraft simply did not exist. For every American loss, the factories at home could replace the machine, and often the pilot, within weeks. The role of mass production. This disparity was no accident. It was the direct consequence of industrial strategy. American production lines ensured that carrier air wings were always at full strength. Spare parts, engines, ammunition, and replacement aircraft flowed across the Pacific in quantities unmatched by any other power in the war. The Essex class themselves, designed with expansive flight decks and efficient maintenance spaces, enabled rapid refueling, rearming, and relaunching. They could cycle sorties at a tempo the Japanese could no longer counter. Japan, by contrast, had exhausted its pre-war elite pilots and lacked the fuel, industrial capacity, and training time to produce replacements. Even when Japanese aircraft managed to lift off, they often entered battle with inexperienced aviators flying machines inferior to the latest US designs. The outcome was tragically predictable: an air arm shattered beyond recovery. The result: the Battle of the Philippine Sea effectively destroyed Japan's carrier-borne aviation. From this point forward, the Imperial Navy would never again mount a meaningful carrier offensive. American forces seized uncontested control of the skies over the Central Pacific, opening the path to the Mariana Islands and placing Japan within range of heavy bomber strikes. B Battle of Leyte Gulf, October 23, 26, 1944. American force structure. Just months later, the United States demonstrated the full scale of its wartime mobilization at Leyte Gulf, the largest naval battle in history. The U.S. Navy deployed 18 fleet carriers, many of them Essex class, supported by more than 100 escort carriers and nearly 600 carrier-based aircraft. This was naval aviation on an industrial scale, something only the United States had the resources and production system to sustain. Industrial power as tactical power. American pilots launched repeated strikes, resupplying from a logistical machine that seemed inexhaustible. Aircraft, munitions, and spare parts flowed continuously from factories, across supply depots to frontline carriers. Japan, meanwhile, faced severe shortages of trained pilots, aircraft, and above all, fuel. Its once potent naval air arm existed largely on paper. Tactical decisions in the battle were shaped not just by skill or strategy, but by the undeniable weight of American production. The result, Leyte Gulf crushed the remains of the Imperial Japanese Navy, with its battleships crippled, carriers emptied of viable air groups, and naval coordination fractured. Japan lost control of the Philippines and the sea lanes around it. The victory opened the path for American forces to push toward Okinawa and eventually toward Japan itself, momentum powered by a wartime industrial base that Göring had once mocked, but that now dominated the Pacific with overwhelming force. The industrial surge that reshaped America's wartime production did far more than win individual battles. It permanently transformed the architecture of global naval power. At the center of this transformation stood the Essex-class carriers. Designed in crisis, built in unprecedented numbers, and tested across the vast Pacific, these ships became the unquestioned backbone of the US Navy. Their service extended long past World War II. Essex-class carriers operated through the 1950s, 1960s, and into the 1970s, fighting in the Korean War and providing critical air support in the Vietnam War. No wartime vessel better symbolized the durability of American engineering and the strategic payoff of mass production. This dominance rested on what historians now describe as absolute overmatch. Germany and Japan simply could not replace their combat losses. Every destroyed aircraft or fallen pilot represented a gap that their industries and their strained training systems could not fill. The Luftwaffe's collapse in 1943-1944 was not only the result of Allied pressure in the air, it was the consequence of a structural inability to regenerate its forces. As ace pilots were lost and aircraft plants were bombed or short on fuel and materials, German air power faded faster than it could be rebuilt. The United States, by contrast, replaced aircraft by the tens of thousands and trained new aviators with a system scaled to meet global demands. These dynamics reshaped naval doctrine worldwide. Battleships, once the giants of the sea, ceded their throne to the aircraft carrier, a floating airfield able to project power hundreds of miles from its deck. Air superiority, not heavy armor, became the heart of modern warfare. In the end, Göring's miscalculation became a lasting lesson. Misjudging an opponent's industrial strength is not merely an error, it is a path to strategic defeat. In the end, the lesson is unmistakable. Bold ideas and advanced technology matter, but mass production and standardization decide the fate of modern war. The United States proved that when a civilian economy unites behind a single purpose, its output can reshape the battlefield and silence every doubt cast by its enemies. From factories to flight decks, America built the force Göring believed impossible. Subscribe to Iron Beasts World War II to explore the machines and strategies that truly changed the course of World War II. Disclaimer: this episode highlights technological and industrial advantages used by Allied forces. Content is documentary, not propaganda.